Hi, welcome to Powers of 10 and Exponents. So make sure you title your page and write today's date. And titles should be underlined. And first thing we're going to do is just define a couple of vocabulary words. If you could, write this date and title on this page as well for your Powers of 10 Flippy Flappy Foldable, because that way you have them together. So if your notes could go by that foldable as well, that would be awesome. If you haven't done the foldable yet, you just need to get a normal sheet of paper. You can do construction paper or regular lined paper is fine. And fold it in half, long ways going vertically with just a little flat off to the side, so not quite half, but almost there. And then you're going to cut 7 different lines, which will give you 8 spaces, 1, 2, 3, 4, 5, 6, 7, 8, and title them this way. So the first flap is 10 to the 0, the second one's 10 to the 1, the third one's 10 to the second, then you have 10 to the third, 10 to the fourth, 10 to the fifth, 10 to the sixth, and then finally 10 to the seventh. And this little flap you just fold over, it helps you keep it nice and neat in your journal. So title both your notes page for vocabulary and this page, Powers of 10 and Exponents. So we're going to start with our notes, and we're using exponents to show powers of 10, show powers of 10. And there are a couple of vocabulary words. The first one is base, and your base is your number used as a repeated factor. So I'll show you what that looks like in just a moment. But then we also have the vocabulary word exponent. And exponent is the number telling how many times the base is used as a factor. So, for example, if I have the problem, let's say 8 to the third power. So that's real simple. Our base is 8. He's there. And he is the number that, I'm guessing it's going to be he. He's the number that's used as the repeated factor. So when I look for my base, it's the larger number off to the left of the exponent, and it's the number that I'm going to use as a factor in my problem to solve. So my exponent would be here, and it's the smaller number in the corner of the base. So if you notice, the base is the red and the exponent's the blue. So the exponent tells me how many times to repeat my base as a factor. So since I have a 3 as an exponent, that means my base will be used as a factor 3 times. 8 times 8 times 8. So it repeats 3 times because my exponent is 3. So if I did that math, I would know that I could do 8 times 8, I'll start there, and then once I get my product of 8 times 8, then I would need to bring down my next factor of 8 again and multiply 64 times 8 because my base repeats 3 times, and that would give me a product of 512. So that means that 8 to the third power equals 512. 8 times 8 times 8. So we're just going to practice this just a bit with our powers of 10. So it's really important to know the exponents and powers of 10 for 5th grade with bases as 10 and exponents, all of the exponents if you can. It'll be really helpful when you're multiplying. It'll also be really helpful when you are trying to move place values and multiplication of decimals. There you go, finally came to me. So now I have 10 to the 0 power. So my base is 10, which means that however many times my exponent, or whatever the number of my exponent is, that's how many times I'm going to repeat my base. Well, since I have a 0 here, that means that my base repeats no times, it's just 1. So the next one is 10 to the 1st power. And since I have a base of 10, that will mean that my exponent now will repeat 1 time. So that's just 10. So 10 to the 0 is 1. 10 to the 1st is 10. Next, I have a base of 10 and an exponent of 2. That means my base repeats 2 times as a factor. That's 10 times 10, which most of us know is 100. Then I go down to the next, 10 to the 3rd. I have a base of 10. I have an exponent of 3. That means my base repeats 3 times as a factor. So that would be 10 times 10 times 10, which is 1,000. Every 3 digits, comma in front. Now, as we keep going, you might notice a pattern. So our next base is 10 to the 4th power. And let's see if we can find the pattern. Well, I have my base repeats 4 times. 1, 2, 3, 4 times as a factor. So 10 times 10 times 10 times 10. Every 3 digits, comma in front. 1 0, 2 zeros, 3 zeros, 4 zeros. I have 1 0, 2 zeros, 3 zeros, 4 zeros. And the reason for that is the pattern doesn't happen with all exponents and bases. It just happens with powers of 10 because that's kind of the fun trick. But the reason it happens is because you're moving place values. So if I go back to my identity property, I know that I have 1 times 1 is 1, times 1 is 1, times 1 is 1. So whatever place value this 1 ends up in will always be 1 since I'm using a base of 10. Now when I move place values, each place value is worth 10 times as much as the one that's less than it. So, or 10 times less if it's the one next door. So for example, I would say 1 and the 1's place, 10 sets of 1's equals 10. If I said 10 sets of 10, that equals 100 because it's 10 times as much. Well, 1 times 10 is 10. That's why 10 sets of 1 equals 10. And then if I had 10 sets of 10, well, that's each place value is worth 10 times as much. But if I went down in place value, I would know that 10 divided by 10 would be 1. So when I go the opposite way, it's 10 times less than for each place value. So now I'm moving 1, 2, 3, 4 place values. That's how I know to add in 4 zeros. Just a little trick, but that's the mathematical reasoning because you're moving place values when you multiply by 10 because each place value is worth 10 times. So my next one, my base is 10 and my exponent is 5. So that means my base will repeat as a factor of 5 times. That's 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5 times. And that will give me 1, 2, 3, 4, 5 place values to replace 1, 2, 3, 4, 5. Every 3 digits, comma in front. Make sure I have 5 zeros there. Yep, so 10 to the 5th power equals 100,000. Now for my next one, I have a base of 10, an exponent of 6. My base will repeat 6 times. As a factor, and I should have 1, 2, 3, 4, 5, 6 zeros in my product. And that's 1 million. And then last but certainly not least, I have an exponent of 7, a base of 10. That means my base repeats 10 or 7 times. And I have 10 times 10 times 10 times 10. That's 4 times. 5 times 1, 2, 3, 4, 5, 6, 7 times. And that should give me 1, 2, 3, 4, 5, 6, 7. 3 digits comma in front, every 3 digits comma in front, 7 place values, and that's 10 million. And you can keep going on and on and on, but for these purposes, in our example, we'll just stop at 10 to the 7th power. So that is it for our powers of 10 and exponents video. Make sure you have those notes and also your Flippy Flappy Foldable filled in.